Hi, class, and welcome to an example problem for Unit 6.1. In Unit 6.1, we talk about trusses, the method of sections, and how to identify zero-force members. So to illustrate some of these points, I'm using a problem from the 13th edition of the book. It's 6-13, and it looks, at least the frame part, looks kind of like this. Just so you can kind of get an idea, they all eventually sort of look the same. These truss problems, just a big bunch of stuff, and I missed one in my drawing. Apologies. One more. These can be a little bit painful, but ultimately this is our setup. We have this truss. It's supported by a pin here at G and a pin here at A. There is a 20 Newton force acting here at pin E. And what we're asked to find is the force in each member of the truss and to state if the member is in tension or in compression. So when it comes to these sort of problems, there's a sort of logical order of operations. The first thing you're going to want to do is see if you can just knock out anything and identify it as a zero force member. There's simple rules that we use to do that. The two rules that you can use to identify zero force members is if there's a beam or there's a joint where there are only two beams connected and there's no external load applied, then those two beams connected to it must be zero force members. So we actually have that case here. And you can kind of just tell right away, right? Because there's nothing acting at point D, neither of these can have any force in them. Because if this guy has any force in him, then that means that there's going to be some sort of Y component force here, and joint E can't cancel that out. It can't do anything. It has no ability to transfer a force in the Y direction to joint D. So those two must be zero force members. The other condition for there being zero force members is if you have a joint where two members, a joint where there are three members and two of them are collinear, then, and the other one is not collinear. So say you had something kind of like this. If this was the case, this guy, the third guy that's not collinear, must be a zero force number. So we don't have that condition in this particular frame, but we do have one more zero force number, and it is actually we do essentially have that condition right here at joint E. So once the zero force member has been identified, it's basically the same as if it's gone, it's not there. So if you look at this one sideways, basically we have that condition right where we have a beam and a collinear force, and then this guy is not collinear with these two, so it must be zero force. So we can state right off the top that F CD equals 0, F CD equals 0, and F FE equals 0. So good job. We found it. So we identified our zero force members. That helps us just not have to spend as much time actually solving. So that's like step 0 of these problems. The next step is to find our reaction forces. We want to find the reaction forces, and this is just building off what we did in Unit 6. So we'll follow the same thing. You may notice, hey, at point G, that's a pin. Shouldn't have a Y force, a Y reaction force. And the reason it doesn't is for the same reason that this guy's a zero force number. Technically, you could write one. You could say, yeah, there's a GY, but by inspection, you know that's got to be zero, because what is going to because this beam it's a a two force member, there can only be a force a collinear. It can only support a force collinear to it. So there would be nothing for GY to resist. So it is by inspection, GY is zero. So, all right, we want to solve for our reaction forces. So we're going to do that by, I'm going to, again, use whatever is the most convenient to, we have three unknowns, we have three equations of forces in x, y, and the sum of the moments. If I do the sum of the moments about A, then AX and AY are not going to be part of that equation. So let's do that. I'm going to do sum of the moments about A equals 0, and 0 is going to be C. So GX is going to cause a negative moment. So it's going to be negative GX times 4. And this force would also cause a negative. So that's negative 20 times 6. And I end up getting that GX equals minus 30 kilonewtons. So it's minus, right? So that just means GX is actually, in reality, pointing the opposite direction. So let's keep track of that. All right, so now that we got that, we can solve for AX super easy. We do sum of the forces in X equals 0, and that's going to be AX plus GX, and AX must therefore equal positive 30. Right, that's got to resist GX. And now we can do sum of the forces in Y. And in Y we have AY minus 20. So therefore AY must equal positive 20 kilonewtons. All right, so we got those. So now that we have our zero force members identified and we have our reaction forces solved for, with the method of joints, you just move along the truss joint by joint, solving for the forces acting on it. And you're going to want to pick a joint where you only have one or two unknowns. So you don't want to pick joints where there's a lot of things you don't know, because we can only, with a joint, when we solve for a joint, we can only solve for two unknowns at a time, using the sum of forces in X and Y. So what we're going to do is I'm going to start with joint G. And with each of these, you are going to draw a free body diagram. So I'm going to say this is joint G. My free body diagram is going to look like this. Dx, F, G, B. And in my free body diagrams, just to make life simple, I am always going to draw the forces in the beams in tension, or going away from the joint. And if I just always draw it in tension, then that means that positive, a positive number means that it's in tension, a positive answer means it's in tension, a negative answer means it's going to be in compression. But I don't have to get confused by which direction I should be drawing arrows. I'm just always going to draw them in tension and let the signs of my answers tell me if it's in tension or compression. So we get this. We've already found gx, right? So we're just going to do sum of the forces in x equals 0. Equals gx plus FGB. And of course, we know gx is minus 30. And so we end up getting that FGB equals positive 30 kilonewtons. And that's a positive answer. So that's intention. There we go, FGB. Next, I'm going to go to point A, joint A. In my free body diagram here, it's going to look like this. A, Y, A, X. So I'm drawing those just like I drew in my picture, but now the force from the beams, from these two force members, we're going to draw in tension. FAB, FAF, 0. So I'm going to, so both of these unknowns have X components, but only FAB has a Y component. So I'm going to start with some of my forces in Y. 0 equals AY plus FAB. And I got to find its Y over hypotenuse. So that's going to be 4 divided by the square root of 4 squared plus 2 squared. Which ends up getting me 0 equals 20 plus FAB times 0.8944. And FAB equals negative 22.36 kilonewtons. It's a negative, so it has to be in compression. And now I'm going to do some of the forces in X. 0 equals AX plus FAF plus FAB times 2 over square root of 4 squared plus 2 squared. And that gets me 30 plus FAF minus 10 when I do that math. And it gets me that FAF equals minus 20 kilonewtons, and therefore in compression as well. All right, so that is joint A, and now we're just gonna keep marching along. So we've done these, so we can go to either joint F or joint B next. So let's go ahead and go to joint B. So my free body diagram here looks like this: F, B, G, F, B, C, F, B, F, F, B, A. So you notice, even though I know that FBA is going to be in compression, right? I found it FAB to be in compression up here. I still am going to draw it in tension. And when I substitute in the value for it, I'm just going to substitute in negative 22.36. Again, that's just the way I prefer to bookkeep it. Just draw everything in tension and just let the sign tell me. Let the math fall out that way. Otherwise, I just find it really confusing, especially when you're going, from, okay, I found the force in this direction here. Which way should I, what does that mean on the next graph? Should I draw it differently? How should I substitute in the answer? Just draw everything in tension and substitute in, let the math fall out. So got joint B. So we do some, I have, in this case, 2 unknowns. I already know FBC or sorry, this is FBG. I already know FBG, I already know FBA. I don't know FBF or FBC, but they're one is totaling the X direction, one's totaling the Y direction, so this will be really easy to solve. I'm going to start with the sum of the forces in X. Going to be 0. That's going to be minus FBG plus FBC minus FBA times, right, the same X part over the hypotenuse, 2 divided by root of 4 squared plus 2 squared. And that gets me 0 equals minus, see, FPG is a positive 30. So minus positive 30 plus FPC, don't know yet, that's what I'm solving for, minus FPA is a minus 22 point, I guess it's 0.36. No, let's just get to it. When you do that, when you substitute in the minus 22.36, do all that math to get 10. And then I know that FBC, therefore, equals 20 means, and it's positive, so that's in tension. Now, sum of the forces in Y. It's going to give me minus FBA times 4 divided by square root of 2 squared plus 4 squared minus FBF. And when I do the math, I end up getting that FBF equals 20 kilonewtons. That is in tension. All right. So we're getting close. I unfortunately am running out of space. Maybe I can fit one more column over here if I'm right really small. So let's try. All right, so we've gone for joint B. Let's now go to joint F. So at joint F, what do we have? We have force AF or force FA. We have force FB. We have force FC. And we don't have to draw FE because we already identified it as a 0 force. So we're just going to leave it off. All right, so in this case, we only have one unknown, right? We've already solved for FB. We've already solved for FA. This should go pretty quick. We just need to solve for FC. And FC, we know that, that's at a 45-degree angle, right? Because it's X, it's, right? Yeah, right. For that way, for F, it's going to be a 45 degree. So we'll do, doesn't matter, we can do sum of forces in X or Y in this case. I'll just do sum of forces in X. Sum of forces in X equals 0. That has to equal negative FA plus FC cosine 45 and CF. That means that if I rearrange this, I can get FC equals FA. Where did we find that? We found that right here. We said it is positive, or it's negative 20. So if we plug in negative 20 there, that gets us a plus, but then we move it to the other side, so it's back to be negative. We get a minus 20 divided by cosine 45 we get that FC equals a negative 28.3 kilonewtons of anatomy compression. All right, and now to the last. So here we could pick, the only force we haven't solved now is EC. We could pick either joint C or joint E to solve it. Joint C has a bunch of stuff. Joint E, though, pretty simple. So I'm going to pick joint E because it is simpler. That free body diagram just looks like this. Force EC and 20 kilonewtons. So it's equal 0. We know sum of forces in Y equals 0, and just by inspection, pretty much, we can say FEC equals positive 20 kilonewtons and is in tension. So these sort of problems are a little bit tedious. They take a while. But if you are just careful with your bookkeeping and follow the steps, you'll have no trouble. They're simple, but they take a while, and it's easy to make a math error that then propagates along your whole problem. But again, the order of operations with these sort of problems, with a method of joints problem, solve for your zero force members using our rules. Solve for your reaction forces, and then move along joint to joint, drawing a free body diagram at each joint, and solve for your unknowns. Pick joints where you know preferably, or where you have preferably only one unknown, but you can do up to 2 unknowns per joint if you need, or if those are the options. And then just go along, draw your forces in your beams in tension, or in other words, going away from your joint always, and just let the signs of your answers tell you if it's in tension or compression. Positive will be tension, negative will be compression, and then just in subsequent joints, as you're subbing in values that you've already solved, that way you can just plug in the value exactly as you solved it, and your answer will pop out correctly. So that's pretty much it for method of joints. You just got to be careful and do the work, and you'll do just fine. So as always, reach out to me if you have any questions still, and I'll always be happy to answer them or meet up with you and answer them. So good luck.